Good evening, everyone. Myself Anjali Ramashankar Prasad. I'm a PMRF student at IIT ISM Dhanbad. So today we are going to start with week 6 assignment session on numerical methods NOC 23 MA 94 taught by Professor Amiya Kumar Nayak and Professor Sanjeev Kumar from IIT Roorkee. So let's start with the questions. So here is your first question. You have been given the following table. So following the table, tabular values are given. So this is the table where x0 is 1.0, x1 is 1.1, x2 is 1.2, x3 is 1.3, x4 is 1.4, 1.5 and 1.6. So corresponding to that we have been given the function value. So you have to estimate the f dash at 1.1 and f double dash at 1.1 by using Newton's forward difference interpolation formula. Okay, so just use the Newton's forward difference interpolation formula and calculate f dash and f double dash at 1.1. So please proceed and tell me what you are getting. Is it A, B, C or D? So did you get f dash at 1.1? What are you getting? Which option you are getting? F dash of 1.1 and F double dash of 1.1? Anyone? Did you get the answer? B. Just check your calculations. So the correct option is D. Here the difference table, first you will calculate the difference table. So just write the x column and corresponding f of x column, and then calculate the del f. Okay, that is forward difference. So for that, as we did in the previous assignment sessions, just follow that and you can calculate this 0.414. Okay, for that you just need to subtract this 8.403 minus 7.989. Okay, so you'll get this and divided by 1.1. So similarly you can get del square f. Then calculate del cube of f and del 4f, del 5f and del 6f. Okay, for calculating del f, what you will do? Simply 8.4 minus 8.403 minus 7.989. So you'll get 0.414. Then for second value 0.378, just subtract 8.403 from 8.781. Okay, so you have to calculate the forward difference. So in this way you will get del f. Then by subtracting the consecutive terms you will get del square f. Similarly all the other terms. Okay, so once you have calculated this difference table, now what is here h? The difference between the consecutive terms is 0.1. Okay, so h is equals 0.1. Now we take x is equals to x naught, that is 1.1. Okay, because we have to calculate at that point. Therefore, p will be what? 0. Fine. So for P equals to 0, what is the formula for Newton's forward difference interpolation for f dash? df by dx at x is equals to x naught, where x naught is equals to 1.1. Fine. That is equals to 1 by h times del f naught minus half del square f naught plus 1 by 3 del cube f naught minus 1 by 4 del 4 f naught plus 1 by 5 del 5 f naught minus 1 by 6 del 6 f naught. Fine. Now just substitute the values that you have over here. So here h is equals to 0.1. Okay. Now since x naught is 1.1, so you will take these values as del f naught. So del f naught is 0.378. Similarly, del square f naught is this minus 0.030. Now del cube f naught is 0.004. Similarly, del 4 and del 5 and del 6. Substitute those values. Here del 6 is 0. Fine. So after solving this, he will get f dash at 1.1 as 3.9518. Just check, are you getting it? Similarly, once you have got df by del x, df by dx, now you can calculate second derivative. It is d square f by dx square at x is equals to x naught as 1.1. So it is given by 1 by h square times del square f naught minus del q f naught plus 11 by 12 del power 4 f naught minus 5 by 6 del 5 f naught plus 137 by 180 del 6 f naught. So substitute the values and simplify it. See, are you getting minus 3.7417? Are you getting it? Is it clear? Do you have any doubt? Shall we move to the next question? Is my slide visible? So next question is, the function f of x is tabulated below for different values of x. So for different values of x, you have given the function value. Okay. Now the value of f dash at 10. You have to calculate at x is equal to 10 what is the value of f dash by using Newton's divided difference formula. So calculate it using Newton's divided difference formula. See whether it is 223 or 322 or 233 or 243. So which option you are getting?
233.
Okay, that's correct. So first we'll calculate the divided difference table. For that we will arrange the values of the column x and column f of x. Then we will calculate the first divided difference column. For that we'll calculate the first divided difference. For that just subtract minus 13 from 23 and divide it by 5 minus 3. So it will give you 18. Okay. So next for 146 you will subtract 23 from 899 and divide it by 11 minus 5. That will give you 146. Okay. In the similar manner you will get the first divided difference column. Then for second divided difference column, what we'll do for calculating this 16, how will get it? So for that, just subtract 18 from 146 and divide it by, this corresponds to what? 3 and 11. So 11 minus 3. Okay, so it will give you 16. So in similar manner, just calculate the second divided difference column, then third divided difference column. For that, you will subtract 16 from 40 and divide it by 27 minus 3. Okay, so it will give you 1. Similarly, here you will get 1. Then when you will calculate 4 divided difference, so 1 minus 1, it will simply give you 0. Fine. Now here, x0 is 3, x1 is 5, then x2 is 11, x3 is 27 and x4 is 34. Fine. Now you have to calculate x at 10, right? So just use the Newton's divided difference formula for f dash x, so you will get 233. I hope you all get it. Just check your calculations. So are you all getting it? Shall we move to the next question? Is there any doubt? Shall we move to the next question? the next question is question number 3, that says following table gives the census population in million of a state for the years 1961 to 2001. Okay, so for this particular year 1961, 1971, 1981, 1991 and 2001, you have been given population in millions. So you have to calculate the rate of growth of population in the year 2001. Okay, so calculate it, whether it is A, B, C or D. Calculate what are you getting the rate of growth of population in the year 2001. So here you have to calculate the rate of growth of population in the year means, rate of growth means you have to calculate the derivative of what does we mean here with the that we have to calculate the rate of growth of population in the year 2001. So here as we have to find in which year, right? In year 2001. So just take this as x, represent year by x and represent population by y. Okay, so you have to calculate dy by dx at x is equals 2001. Fine. So calculate it using any of the methods. You can use Newton's backward difference formula. So what are you getting the rate of growth of population in the year 2001? Anyone? Have you got it? So which option you are getting? Either A, B, C or D? So we can do it by any of the methods using Newton's backward, forward or any of the methods. So here we have used Newton's backward difference formula. For that, first calculate the backward difference table. For that, arrange the x values of x, that is year, and corresponding population, and calculate the backward difference. Okay. So just check, are you getting for the first backward difference nebula F as 16.69? So for that, 36.65 minus 19.96, it will give you 16.69. Similarly, 58.81 minus 36.65, it will give you 22.16. So in the similar manner, you can calculate the nebula F. Then for nebula square F, use this nebula F. So 22.16 minus 16.69 will give you 5.47. Fine. So in this way, you calculate nebula F, nebula square F, nebula cube F, and nebula 4F. Now we have to calculate the growth in the year 2001. Fine. So that will be x, at which you have to calculate the derivative of y with respect to x. So dy by dx at x is equals to 2001 will be this. Just use the Newton's backward difference formula for differentiation and you will get 2.08175. Okay. Just check it, are you getting? Is there any doubt? Shall we move to the next question? Okay. So question number 4 is, use the method of undetermined coefficients to find the correct relationship. Okay. So just check which one is the correct relationship. Use method of undetermined coefficients and find what does f double dash of x is approximately equal to. Is it A, B, C or D?
C. Answer.
Okay. Are you all getting it? C? So the nth derivative of the function is expressed as the linear combination of the function of values at an arbitrarily chosen nodal points. Okay. So here just choose xi as arbitrary nodal point. So for that, the nth derivative is given by h to the power n into fn. Nth derivative at xi is equals to summation over k equals minus into n of ck into fi plus k. Fine. So just substitute here. Here you have to calculate second derivative, right? So n will be 2. So h square f double dash at xi is equals to, you just put k is ranging from minus 2 to 2. Okay, so first it will be minus 2. So c minus 2 into f of I, k is minus 2. So f of I minus 2 plus c minus 1, okay, into f of I minus 1 plus c naught into fi plus c1 into, now just put 1 is k is equals to 1. So it will get, you will get c1 into fi plus 1 plus c2 into fi plus 2. Fine. Now here you got h square into f double dash xi as this. Fine. Now using Taylor series expansion, you can also get h square f double dash of xi as this, right? C minus 2 plus C minus 1 plus C naught plus C1 plus C2 into Fi plus H into this into Fi dash plus all these terms. Fine. Now what you do, simply just equate the coefficients, okay, in both the equations of f double dash of xi. So you'll get C minus 2 plus C minus 1 plus C naught plus C1 plus C2 is equals, this will be equal to 0, right? Now this will be also equals to 0. Similarly, all these coefficients you will get, this will be equal to 0, fine. Now solve this algebraic equations. So it will give you C minus 2 equals C2 is equals minus 1 by 12 and C minus 1 equals C1 is equals 16 by 12 and C naught will be equals to minus 30 by 12, right? So hence correct option is C. So when you will put this coefficients in this equation, you'll get f double dash of x as this. Just check it. Yes. Is it clear? Okay. Shall we move to the next question? So next question is, given a cubic polynomial with following data points, you have been given this data points x as 0, 1, 2, 3 and corresponding to that you have been given y as 5, 6, 3 and 8. Okay. So the value of y dash and y double dash at x equal to 0 is, so you have to calculate the value of y dash and y double dash at x equals to 0. Calculate it. Check whether it is A, B, C or D.
It is B.
Okay. Are others also getting this? So we have the difference table as follows. Just write the x values and y values. Next, calculate the del y. For that, six minus five it will give you 1. Then 3 minus 6 it will give you minus 3. In similar manner, you can calculate del y and then calculate the del square y column. So it will be minus 4, 8 and del cube y column. And just apply the Newton's forward difference formula for derivative of y with respect to x. We have to calculate y dash at x equals to 0. So put in that formula, just substitute x is equal to 0. So you'll get 7. Similarly, for second derivative at x equals to 0, substitute the formula, you will get minus 16. Okay, so correct option is B. Is it clear? Shall we move to the next question? Is everyone getting? Shall we move to the next question? Or are you solving it yet? Okay, so let's move to the next question. Question number 6 is, find the value of cos of 1.74 in radian from the following table. Okay, so you have to calculate the value of cos at 1.74, and you have been given x at 1.7. You have been given the sin x value at 1.74, at 1.78, at 1.82, and at 1.86. You have been given the value of sin x. Okay, so using this data, you have to calculate the value of cos of 1.74. So use it and calculate it. See what you are getting. Is it 0.168, 0.175, 0.179, or 0.183? Are you getting it? So here, as you have to calculate cos of 1.74, so using data, given data, as here you have been given sin x, so consider it as y. So when you will take derivative of this, you will get cos x, right? And you have to calculate x at 1.74. So simply you have to calculate the dy by dx at x is equals 1.74. Okay. So use Newton's forward difference formula. Generate the forward difference table and then calculate it. Just calculate dy by dx, take sin x rho as y. So its derivative will give you cos x, and you have to calculate cos of 1.74. So take x is equals 1.74. So what you are getting? Cos 1.74. So here, just take f of x as sin x. So f dash x will be cos x. So we have to calculate f dash at 1.74. So you will get cos of 1.74, right? So first you will find the difference table. So we are using forward difference formula. So calculate the forward difference table. Just arrange the x and the corresponding y values, that is sin x values. Then calculate the forward difference, that is del y. Check, are you getting these values in the first column? So when you subtract 0.9857 minus 0.9916, so you'll get minus 0.0059, right? Then for minus 0.0076, how will you get it? 0.9781 minus 0.9857. So it will give you minus 0.0076. Similarly, you will get the first forward difference, that is del y, and calculate del square y. For that, minus 0.0076 minus of 0.0059, this will give you minus 0.0017. So in the similar manner, you will get del square y, del cube y, and here it will be del 4y. Okay. So let's use Newton's forward difference formula to calculate f dash at 1.74. Okay. That will give you cos of 1.74. So here x is 1.74, x naught is 1.7, right? Okay. Am I audible now? Am I audible now?
Yes.
Okay. So here we have been given x and sin x. So just take sin x as f of x, and then f dash x will be cos x, right? So you have to calculate cos of 1.74. That means you have to calculate f dash at 1.74. That is dy by dx at x equals to 1.74. So for that we are using Newton's forward difference formula. So okay, first find out the first difference table, forward difference table. X, y, del square y, del cube y, and del 4y. Okay. Now Here we have to calculate at x is equals to 1.74. So x naught, take, as we are using forward difference, so take x naught as 1.7 and h will be the difference between the consecutive terms, that is 0.04. Okay, so this will give you p as x minus x naught by h, that is 1, right? So just substitute in the for Newton's forward difference formula, that is dy by dx at x is equals to 1.74 is given by 1 by h times del y naught minus 1 by 2 del square y naught plus 1 by 3 del cube y naught minus 1 by 4 del 4 y naught, right? So here x naught is 1.7, so you will take these as del y naught, del square y naught, del cube y naught and del 4 y naught. Okay, so take these values and solve. See, are you getting 0.175? Here it should be minus 0.0059. Okay, check, are you getting 0.175? Just a minute, I'll just retrieve my connection. Till then, please try to solve the question. So are you all getting dy by dx at x is equals 1.74 as 0.175? That means cos of 1.74 is 0.175. Just check your calculations. And if it is clear, then let me know. Then we'll move to the next question. Is it clear to everyone? Shall we move to the next question? Okay. So next question is, from the following tabular data, that is x at 0 to 4 6 and corresponding y you have been given 2 0 minus 50 and minus 196. You have to calculate the maximum and minimum value of y. Okay, so calculate it. Is it 4 comma 0, 0 comma 4, 0 comma 5 or 1 comma 4? Calculate the maximum and minimum value of y. So did you get the answer? For calculating maximum or minimum, you have to first calculate dy by dx. Okay. So are you getting it? Anyone? So first calculate a difference table. For that, arrange the both the columns x and y and find del y, del square y and del cube y. So 0 minus 2 you will get minus 2, minus 50 minus 0 you will get minus 50, then minus 196 minus 50 you will get minus 146. Similarly calculate del square y and then calculate del cube y. Okay. Now here x naught is 0, so p will be x minus x naught by h. By using forward difference, yp is given by, okay, so first 2 plus p into this del y naught, that will be minus 2 plus p into p minus 0 by 2 factorial into del square y naught, that will give you minus 48, plus p into p minus 1 into p minus 2 by 3 factorial, that is 6, into del cube y naught, that is minus 48. So simplify it, you will get minus 8p cube plus 6p plus 2. See, are you getting it? Now once you have got yp, so for finding yp means you have got dy by dp, right? Sorry, dy by dx. Okay, we are representing it with yp. So once you have got dy by dx, then the maximum value of y will be at what? When you will equate dy by dx is equals to 0, right? So just equate this. First find dy by dx. This is your y minus 8p cube plus 6p plus 2. So dy by dx will be, since it is a function of p, we are representing it here yp. Okay, so when you will calculate dy by dx at p, you will get minus 24p square plus 6, right? Now when you will equate it to 0, you will get the maximum value. So just equate dy by dx is equals 0. You will get p. See what you are getting? You will get p is equals to plus minus 0.5, right? So just substitute that p over here. You know x, you know h. Okay. So substitute, you know x naught. Once you have got P is equals to plus or minus 0.5, just substitute here. Yp is equals minus 8pq plus 6p plus 2. So when you'll put P is equals to 0.5, see what you are getting. And when you'll substitute minus 0.5, see what you are getting. The value of Y. So when you substitute P equals 0.5, here you will get Y is equals to 4. And when you substitute minus 0.5, you will get Y is equals to 0, right? So correct option is A. Fine. Are you all getting it as option A? The maximum and minimum value of Y? Is there any doubt? Is it clear to everyone? Shall we move to the next question? Okay. So next question is, the following data represents the velocity of a particle for 20 seconds at an interval of 5 seconds. Okay. So at 0, at 5 seconds, at 10 and 15 and 20 seconds, you have been given the velocity of a particle, that is 0, 3, 14, 69 and 22, 28 respectively. So you have to calculate the acceleration at time t equals to 0. So calculate it. Here we have been given velocity. You know acceleration. What is acceleration? Rate of change of velocity with respect to time, that is dv by dt. So you have to calculate dv by dt at time is equals to 0. Okay. Use any of the methods. You can use Newton's forward difference formula and calculate the acceleration at time t equals to 0. Tell, have you calculated dv by dt at t equals 0? What you are getting? Is it 0.50 millimeter per second square, or 0.75 meter per second square, or 1.00 meter per second square, or 1.25 meter per second square? So let's first calculate the difference table. As we are using Newton's forward difference formula, so calculate the forward difference table. Arrange the values of time and velocity uh, accordingly, and then calculate del v. That is 3 minus 0, you will get 3. Here 14 minus 3, you will get 11. Similarly, calculate del v, then calculate del square v, then del cube v, and del 4 v. We will get this difference table. Now, using the Newton's forward difference formula, you have to calculate dv by dt at t equals to 0. That will be approximately equals to 1 by h times del v naught. Okay. So, here as we have to calculate at t equals to 0, right? So, take these values. So, del v naught will be 3. Take the first two values. Okay. So, del v naught will be 3. Then del square v naught will be 8. Del cube v naught will be 36. And del 4 v naught will be 24. Substitute all the values and solve. See, you will get 1. Okay. So, the acceleration at time t equals to 0 is 1 meter per second square. Is it clear? Check your calculations. Are you getting the acceleration at time equals 0 as 1 meter per second square? Okay. So let's move to the next question. So from the following data set, you have been given the data set uh, for x and y values, and you have to find dy by dx at x is equals to 900 using Stirling's interpolation formula. Okay, so use Stirling's interpolation formula for the following data set and calculate dy by dx at x is equals to 900. See whether it is 0.094, 0.085, 0.079 or 0.074. what is the correct answer you're getting? Is it B, 0.085? So for using Stirling's formula, first calculate the forward difference table. For that, arrange the x and y values and calculate del y, del square y, del cube y, del 4y, del 5y, and del 6y. Then using Stirling's formula, you have to calculate dy by dx at x is equal to 900. So just substitute the values in the Stirling formula. So here you have to calculate at x is equals 900, right? So take this as the x naught. See, are you getting 0.085? Are you getting 0.085? If you just substitute the values in the formula, you'll simply get it as 0.085. Now, shall we move to the next question? Okay. So last question is, following data set represents the value of y for different value of x. So here you have x 0.60, 0.65, 0.70, 0.75, and corresponding to that you have y values 0.6221, 0.6155, and the rest. So find the value of x for which y is minimum. Okay. So using the data set, you have to calculate x for which y is minimum. Is it 0.67? Is it 0.68, 0.6923, or 0.6974? Calculate it. Did you get the answer? For the last question, I'm just checking my network connection. So here, first we'll calculate the difference table. So arrange the x and y values and calculate del y, del square y and del cube y. Then here x naught is 0.60 and h is the difference between the consecutive term is 0.05. Now Newton's forward difference formula for differentiation, it will give you dy by dx. Okay, so that's approximately equal to these values, right? Minus 0.0066 plus 2p minus 1 by 2 into 0.0049. Now we have to calculate the point x at which the y is minimum. Okay, for that first let's find the optimum point. So that is dy by dx is equals to 0. This will give you, when you solve this, it will give you p is equal to 1.8469, right? Now what is actually have to calculate? The value of x, okay? But p is what? X minus x naught by h. So simply put the value of x naught, that is 0.60, and h and p you have got at which the value of y is minimum. So just substitute it over here. You will get x as 0.6923. Okay. So at x is equal to 0.6923, the value of y will be minimum. Okay. So correct option is C. Is there any doubt? Okay. So these were the questions that were to be discussed for week 6 session. I hope everything is clear. If you have any doubt, you can tell me in any of the questions. Okay. So thank you everyone for joining the session, and we'll meet in the next session, okay, on next Saturday. Thank you everyone. Thank you.
Thank you, ma'am.
Thank you. Thank you. So I'm leaving the call if everything is clear. Thank you.